For this lesson, we are going to review graphing equations. A reminder for slope. Slope is the change in y over the change in x. And then we're going to write this as rise over run. So how much is it going up or down is your rise. And then how much is it moving left or right? That's your run. So slope should be a fraction. If slope is a whole number, for example, we have a slope of 3, we would write that as 3 over 1. So our rise would be 3, and our run would be 1. And if the numbers are negative, that's when we would go our negative directions. So instead of rising, we'd go down if it were negative. And if it's a negative on the bottom, we would go left instead of right. And remember equivalent slopes. So if you have 1 over 3, that is equivalent to negative 1 over negative 3. So if, for example, you don't have enough room to go up 1 and right 3, you can go down 1 and left 3. Or we could also have negative 2 over 5 is equivalent to positive 2 over negative 5. Again, you can use it if you don't have room to go down 2 and right 5. You can switch it and go up 2 and left 5. As long as you're making them both the opposites, these are equivalent slopes. You can even check by turning them all into decimals, and you would see that the decimal for 1/3 is the same as the decimal for negative 1 over negative 3. Same with negative 2 over 5 and 2 over negative 5. Those would have the same decimal values. Y-intercept is where the graph crosses the y-axis. And when we graph a line, we're going to start with the y-intercept, and we'll have that as our starting value, and from there we'll graph our slope. And then slope-intercept form, that is y equals mx plus b. And as a reminder, the m stood for our slope, and the b was our y-intercept. On number 1, we already have an equation in slope-intercept form. Our y-intercept is 3, so on the y-axis, we'll go up to 3, 1, 2, 3, and that is going to be our starting point. From here, notice that we have a negative out front, negative 2 over 3. I can make either the 2 or the 3 negative. It doesn't make a difference which one. I'm going to go ahead and make the 2 the negative. So in this case, I'd go down 2, and then right 3, and then I make another point. And then you want to draw a line, continuous line all the way through those points with arrows on both ends. For number 2, again, it's already in slope-intercept form. My y-intercept is negative 2, so I'm going to start on the y-axis at negative 2. The slope I need to make a fraction, so 3 becomes 3 over 1. And they're both positive. I'm going to go positive 3 up, 1, 2, 3, and 1 to the right. Make a point, and then I'll draw my line through that. And then also a quick reminder that if your slope is positive, like a number 2, it should go up as we're going left to right. And if it's negative, like a number 1, it should be going down as we go from left to right. So that's a really quick visual to check when you're done. Make sure you've got the positive slope graphed positive or negative slope graphed as it should be for negative. For the next one, we have to rewrite this equation in slope-intercept form first so we can see our slope and our y-intercept in order to graph it. So this one we're going to do like we did in our lesson on rewriting equations. So we're going to get the y by itself so that it is in slope-intercept form, has y by itself. So we'll do minus 4x on both sides first. That's going to give us 2y equals negative 4x plus 10. And then we divide every piece by 2 until we have y equals negative 4 divided by 2 is negative 2x, and 10 divided by 2 is a positive 5. So that simplifies to y equals negative 2x plus 5. So my y-intercept is 5. 1, 2, 3, 4. If we start at y is 5, from that point, we're going to count our slope as -2, which is -2/1. So -2 down 2. +1 is right 1. And then we can draw my line all the way through. And then I want to just real quick glance, my line's going down, my slope was negative, so that matches. And on our last one, again, we've got to rewrite this so that it is in slope-intercept form. So we're going to add 3x because it's already negative, so the opposite is do positive 3x on both sides. That's going to give us -4y is equal to a positive 3x minus 16. Then we're going to divide everything by -4. And that's going to be y equals 3 over -4. I can't reduce it. We could leave the negative sign at the bottom. You tend to see the negative sign written on the top, but it doesn't make a difference. So I'm going to say -3 over 4x. You could leave it as 3 over -4x. And -16 divided by -4 is a positive 4. So we have y equals -3 over 4x plus 4. So my y-intercept is 4. So on the y-axis, I'm going to go up to 4. And that's my starting point. So from that starting point, I'm going to count my slope. -3, that's down 3. 1, 2, 3. +4, that's right 4. 1, 2, 3, 4. If you had left that slope as a +3 over a -4, and we went to graph, and we started on our point, there's actually no room to go up 3 here. So that's when you would want to use those equivalent slopes so we can have room on our graph. And then once we have it plotted, we draw our line, and then we check our slope is negative, our line's going down, so that matches.